and welcome to the wolfSSL live webinar, How to Use wolfSSH on Windows, presented by wolfSSL software developer Jacob. My name is Shizuka, and I will be moderating this webinar. All attendees will be in listen-only mode. If you have questions, please use the Q&A box. We will host a Q&A session following the presentation. The webinar will also be recorded and made available on YouTube channel shortly after the presentation. I invite you to follow us on Twitter at wolfSSL, as well as our other socials. Also, feel free to email us if you have any additional questions. And now I would like to give a brief company overview before we move to the technical presentation. Today, wolfSSL secure over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. wolfSSL is made up of over 50 dedicated employees, most of which are engineers. This progress is of course supported by the strong partner network that we are proud of. Since the beginning, our engineering team has developed several embedded security products, including wolfCrypt with DO-178 support, a FIPS certification, and a FIPS-ready offering, MQTT up to the B5 specification, SSHv2, TPM 2.0, a secure bootloader known as wolfboot, as well as Java wrappers and JSSE support and commercial support for Coral. All of these offerings are accompanied by through maintenance and support plans up to the 24/7 level. We also offer full service consulting. And now I would like to turn it over to Jacob to talk about how to use wolfSSH on Windows.
Thank you, Shizuka. Before diving into wolfSSH on Windows, I'd like to give a little overview of what exactly wolfSSH is. wolfSSH is a software library implementation of the SSH secure shell protocol. It includes both SFTP, secure file transfer protocol, and SCP, secure copy protocol implementations that run on top of an SSH connection. And it makes use of wolfCrypt to handle all crypto operations. This is nice because wolfCrypt is one of the best tested crypto libraries out there, and it gets all the benefits that you would see from plugging in wolfCrypt for the crypto operations. Some of the most common applications is embedded systems. This can be like an embedded SSH server. It's also been used for remote management if you want to log into an edge device and do some configurations on it. To be able to run shell commands on embedded devices, remote devices, do debugging on them, transferring files. Transferring files can be done with things such as if you wanted to transfer a firmware update or really any other type of bundle that you'd like to transfer over to a device. So wolfSSH isn't unique in that it's the only SSH implementation out there. There's a lot of SSH implementations. So why would someone use wolfSSH? Some of the reasons that you would use wolfSSH over another implementation is the portability of the library. It's been ported to many different embedded devices and RTOSes. It has an IO file system and authentication callbacks, making it pretty easy to use different types of transport mediums or different file systems and customizing how the authentication is processed. It's lightweight and embeddable. It was developed with embedded devices in mind. With using wolfCrypt, it gets the ability to have the FIPS 140-2 or the newer 140-3 certification. So if working with the government or some kind of application where you need FIPS certification, it's possible to do that with wolfSSH. It's dual licensed. We have the GPL v3 version of it up on GitHub. We also have a commercial version of it available, so it can be used in both GPL open source projects as well as in a commercial project. And we have active support and maintenance available. All of the original authors of the wolfSSH code are still with the wolfSSL team, so they'd be available to answer questions and help through support. Some of the features that wolfSSH has is its modular build. This lends itself well to resource-constrained or embedded devices where you can trim out the RSA operations and only have ECC, or vice versa, just have RSA operations and no ECC operations. As mentioned before, it has SFTP, SCP implementations. It also has port forwarding, X509 certificate support. This is nice to be able to verify a connection using a certificate chain. It also has SSHd support, which was added recently. Last couple of releases had the Linux Unix style version of the SSHd in them. One of the more recent things that we've done with that is the Windows port that we'll go into more detail on. It also has key generation in wolfSSH and small stack build. Small stack builds are nice if you have some kind of device that has more flash memory than RAM. That way you can push more of the memory towards the heap rather than having it on the stack. Kind of a high-level overview of the topics being covered. We'll start off with building wolfSSH on Windows, move on to wolfSSHd on Windows, which is one of our new ports for wolfSSHd. Some of the options supported. Then once having built the applications, how to go ahead and use them, running it as a service, running a client on Windows, SFTP, and then at the end, we'll go over a few tips and tricks and have a option for questions. So to begin with, building wolfSSH on Windows, first need to have wolfSSL. This is to build and use the wolfCrypt for the crypto operations of wolfSSH. And then also, obviously, the wolfSSH bundle. There is a Visual Studio included in Visual Studio solution, included in wolfSSH that has preset locations where it looks for the wolfSSL library. To be able to use the preset and easiest setup, you need the wolfSSL and wolfSSH directories in the same folder. So as shown here, it has wolfSSL and wolfSSH. The naming is important also for wolfSSL because of the preset location that the wolfSSH project is looking for the wolfSSL library. The next thing to do is to copy over the user_settings.h from wolfSSH to wolfSSL. This user_settings.h is located in wolfSSH IDE WinVS. All of the Windows porting files, such as like the Visual Studio solution, is located in this IDE WinVS directory. Then you would build the wolfSSL project using the wolfSSL Visual Studio solution. This is wolfSSL 64.sln. And it's important to have copied over the user_settings.h first, because you want to make sure that both the wolfSSL library and the wolfSSH library are built with the same user_settings.h settings. This kind of configures what macros are set and defined, so it determines how the library has been configured. After having built wolfSSL, you'd then go on to build wolfSSH using the Visual Studio solution. There's also a README located in this directory that goes over these steps too. So it's kind of nice to have that there to be able to reference. And you can see the location of the other projects in here, like the Echo Server test suite, for example. When opening up that Visual Studio solution, one option is to just build the whole solution. This builds all of the projects available. Another option is to go in here and you can right click and select to build individual projects, such as if you only want to build the client. There's support for multiple different configuration as far as how it's built. We have debug, release, and the DLL release, DLL debug. Depending on if you want it as a DLL project or as a more of a static kind of library. So those previous steps was just building with the generic user underscore settings.h that is bundled in wolfSSH. And our generic build doesn't, or the default settings, I should say, doesn't have SSHd enabled. It's just the library itself. A lot of people who are just linking against the library only want to send information directly across SSH connection, not necessarily having to deal with like a pseudo terminal or a shell connection or more advanced options. So to be able to build with wolfSSHd on Windows, you'd have to have additional macros added to that user underscore settings.h. The two main ones required are wolfSSH underscore SSHd and wolfSSH underscore shell. Some of the optional macros that are typically used with SSHd, though, is enabling both SCP and SFTP support. And that can be done with these two macros, the wolfSSH underscore SCP and underscore SFTP. The bulk of the Windows SSHd support, like I mentioned, had been added relatively recently. The support was added in the GitHub pull request 5.12, and then there's been quality and slight fixes since then as well. But that was after the wolfSSH release 1.4.14. So this wolfSSHd Windows port will be out in the next release, but it's also available on our master branch right now to be able to download and use. We did some adjustments to the user underscore settings.h to make it easier for turning on SSHd. There's a section in the user underscore settings.h that has like a if zero guard on it, macro guard on it as a default. And then to enable SSHd and the common options used with it, SCP and SFTP, you can just adjust that to a 1. You can see the tail end of it here in this user underscore settings.h image, but there's also a X509 block similar to like this SSHd one. And that's just to help make it easier to enable what people would typically use with SSHd if you wanted to enable. And obviously, you can go in here and you can tailor it to your use, such as if you don't want SCP support or SFTP support, those can be commented out and not defined. So after going through and doing all these build steps, the next question is, where exactly is this executable being output at? The location of the resulting executable will be in, well, it depends on the build configuration. In this particular case, it was a debug build, but it'll be in wolfSSH, IDE, WinVS, the build configuration, debug, release, DLL, debug, and then the architecture, x64 or Win32. In this case, it was x64. And then you can see down here, you have the wolfSSHd application. So there's a good number of options supported by the wolfSSHd implementation. Part of how we set up the arguments and the SSHd config file is to make it easy to be able to replace OpenSSHd, or just make it familiar for people who have already worked with OpenSSHd. And this kind of lends itself well to people who are swapping over from OpenSSH or have worked from it before, because they don't need to climb back up the learning curve of what options and what configures to be using. Right now we have the -F to be able to set like the configuration file to use. This is like the common SSHd underscore config. It also is looking in the same default location as what an OpenSSHd application would be looking in. And we have -p for port number, debug, -D for running in the foreground, -h for loading a host private key file, and -E for setting a specific logging file. Some of the SSHd underscore config options that we're able to parse are like the authorized keys file for setting up which keys are authorized to be able to be connected, permit empty passwords, protocol. We only allow protocol 2, the login grace time, host key to use, whether or not password authentication is supported, port to bind to and listen, the option to be able to permit logins, include for if you want to include another config file. We also support chroot directory. That has more effect on like a Linux Unix style environment than it does on Windows, but it's able to be parsed. And then we have match and force command, which is really useful if you have specific users that you only want to allow SFTP connections for those users. You can do the force command to force them to only be able to use SFTP connections, or it's not limited to that. You can force any type of command that you'd like for users that are in that match list. We have the host certificate, trusted user CA keys, and PID file output. There's a couple of other options that we are able to parse as well, but they're more considered like a no-op or don't have much effect with wolfSSH, so I didn't list them here. So once you've got all the configuration set up for how you want the SSHd to run, the next steps are actually setting it up as a service with Windows. This command here, sc.exe create, shows an example of doing that, setting it up as a service. And for simplicity, I named the service wolfSSHd. Then what you could do is you could set the bend path equal to wherever the SSHd executable is located, and then add your -f for which file it should be loading for the additional parameters. It's important to add the arguments that is going to be used with the wolfSSHd executable in this bin path, especially if you want to later set it up as an automatic service that starts up when the system boots up. An example of starting the service from the terminal would be this sc.exe command followed by start wolfSSHd, and then you can see some of the output here where it shows its start is pending. And obviously you can do sc.exe query after it's started up to show whether or not it's running or stopped, and the sc.exe stop command to be able to stop the service. So on some systems, if you want to have wolfSSHd start up automatically, you can go to the services options, scroll down, find your wolfSSHd service, then set the startup type to automatic. By default, at least with the command I showed previously, it's a manual startup type, so you'd have to start it up each time. But adjusting the startup type to automatic just makes it so it starts up when the system starts running. And again, it's important that the arguments had been included in the bin path here. So that's a lot about the wolfSSHd running on Windows. Again, that wolfSSHd on Windows, it also supports the SFTP connections and SCP connections, pseudo terminal connections. I should also mention that it's for Windows 11 and later versions of Windows 10, just because of how it's setting up the pseudo terminal. So it is right now for newer versions of Windows that it would work. This next couple of slides are going into the client application. So to be able to build the client project in Visual Studio, you can, as mentioned before, just right click on the client project and build it specifically. Or if having built all of them with build solution, it also have them been built in the same directory as the wolfSSHd executable was. There's quite a few options that are supported by the client. These are going to be the same options that you would find on like a Linux, Unix environment. So it has the host that it's connecting to, port, username, which is required, which username it's going to be logging in as. You can also pass the password. You can do pass in the file name for the user's private key as well as public key. And -X option is nice if benchmark keying like the time per connection. That just does a connect and doesn't do any read and write operations. It also has non-blocking pseudo terminal with -T, which is what a lot of people typically think of with like a SSH client is doing opening a pseudo terminal. Execute a specific command and then pipe the standard in, standard out with -C. And -R is a raw untranslated output. Basically what that is there's some special characters and escape characters. I like to think of them with Linux, but it's not limited to Linux. Just often when Linux and Windows consoles are communicating back and forth, these special characters sometimes aren't read very nicely. These special characters have to do with like where the cursor location is, colors of the font, bold versus non-bold, italicized, special commands that are being done. And we have support for parsing a lot of those special commands. -R just basically passes the data that's receiving unfiltered, so it's not going through our translation code. And this is an example of opening a terminal against wolfSSHd. So having done all the steps previously to set up wolfSSHd as a service and start it running, then you can go ahead and run the client executable, in this case with the user Fred, and -T to open the terminal connection. There's also some additional development being done on the client side. Part of this is making it even more robust than it currently is. One of the robustness that's being added is easier installation of the client. And then there's also easier drop and replace for an OpenSSH client. We're adding in the support for the user at host kind of input that the client that a lot of people are familiar with running a client. Those client side improvements are set for the next release as well. One of the other projects that we have on Windows is the SFTP client. This is located in that wolfSSH Visual Studio solution. You can right click on wolfSFTP-client and build it individually, or if having done that build solution, it would be in the same directory as the client executable and the wolfSSHd executable. There's quite a few options available with the wolfSFTP client. The standard ones that you'd expect with host, port, username, but it also has a -D option to be able to set the default local path. This is useful on Windows because sometimes you'd like it to be set to a default path other than when the executable is being started. So that's nice to be able to set that default path. It also has the non-blocking, and then what we call like an autopilot kind of option with -G and -G. This is SFTP often starts up as like a type of interactive terminal, but SFTP can be just a single call to get a file or put a file onto a system. So this -G and -G allows you to just do like a single file transfer without having to open up that terminal and enter exactly what you'd like for the commands in that terminal. And then this one was built with X509 certificate support, so you can see the -J there. That's for a dir certificate. -A is for the dir CA certificate for verifying the host, and then it also checks the IP address if present in the certificates being authenticated. So -X is a way to be able to ignore the IP checks if that's not important with the connection. And on the bottom here, it shows the typical SFTP commands if it is opening up in interactive mode. You have the change directory mode and list directory. And this is an example command of using the wolfSFTP client. Again, you need to pass the username and then the host that you're going to be connecting to. So a few tips and tricks when running wolfSSH on Windows. You can enable debug messages with the macro debug_wolfSSH. There's an equivalent debug_wolfSSL as well. This is helpful for if wanting to see extended debug information. If using a DLL build, the wolfSSL DLL and wolfSSH DLL need to be in a location where the service can find them. If you're starting up a wolfSSHd service, that is. An example of that location would be like the Windows System 32. If wolfSSHd does not start up, I mean, if it has the behavior of you click the startup and then it shuts down immediately after the start, it's likely an issue with finding the SSHD_config file. Some of the path might be incorrect, or the SSHD config file might not be able to be opened, or the DLL libraries could be not being found if built with the DLL build configuration. Those are the two most common gotchas that I've ran into on the Windows wolfSSHd server if it's not starting up like it should. Yeah, and that goes over how to build wolfSSH, the library on Windows, how to build the new wolfSSHd port on Windows, and how to make use of it and connect to it with some of our client applications. And at this time, I'll go ahead and open it up for if there's any questions.
I do have a question. So, do you have an MQTT client only, or broker and a bridge too? Do you have a TLS support with MQTT?
Yeah, we do have TLS support with MQTT. We have or Wolf MQTT, which is a separate product from wolfSSH, but it does have TLS support. We don't have a broker implementation. That is something that's been brought up and potentially on the roadmap, but we just have the MQTT client side.
I do have another question. Can it be reasonable to use SSH on non-Linux embedded devices? For example, with RTOS on constrained devices, are there such practical scenarios?
Yep. I guess the short answer is yes. We target a lot of embedded devices. We've been used with FreeRTOS, MQX, and MQX, along with a couple of other RTOSes. And there are use cases for that. One of them is being like firmware updates for sending a bundle securely to some kind of resource constrained device for a firmware update. Other use cases are if wanting to send back like debug information from some kind of device you might not have a lot of resources to work with and just want to send back debug information securely.
I have another question. Do you have a binary distribution of wolfSSL for Windows?
Right now, we do not. We just distribute the source code, and then it has to be compiled.
Another question. Yes, go ahead.
Yeah, I was going to bring up though, we have a couple of additional bundles that we've started to do with like Debian packages and RPMs. Those ones aren't going to be for Windows though. It's going to be for more like a Linux, Unix kind of environment.
Another question. Do you have a library variant of wolfSSH or it is executable only?
So it is a library. What we added on top of that library was the additional executables. wolfSSHd makes use of wolfSSH, and then the client and the SFTP client applications make use of wolfSSH. But there's the option to just build wolfSSH as a library and have your own application call the APIs. For example, we have like a wolfSSH underscore accept that does the SSH protocol accept, or vice versa. The other side, we have the wolfSSH underscore connect that does the connect portion of the SSH handshake. And then you can call a read or a write API that we have to just pass information across that connection.
I do have another question. When consuming wolfSSH DLL from Python or other scripting language for commercial project, it is aligned with GPL license. What are limitations in such case?
That one is a little harder for me to answer. It might be best if we went through like one of our salespeople to answer that one. But at a high level, the GPL v3 just put restrictions on kind of all code that links to it and is being used with it. It needs to be also GPL'd. And then the commercial allows you to be able to ship it in more of like a closed kind of closed source way. It's the same code base in both our GPL v3 and our commercial. It's just how it can be shipped.
If you have any licensing question, just email us for the fax at wolfSSL.com so we can introduce you guys to the sales directors. And I do have another question. Can only SFTP support be enabled and all other components disabled for smaller footprints?
Yes, that can be done. I know that I'm not as sure with the SSHD. I haven't I don't remember testing that off the top of my head, but I did put macro guards around the shell. So shell code and SFTP code and SCP code, so it should be supported with that as well. But I know the source code itself, just like the main wolfSSH library, you can enable just SFTP and not have shell support or SCP support enabled.
Another question, can other compilers be used instead of Microsoft VS compilers?
Yeah, we've done a lot of development with GCC compilers obviously on the Linux side. I haven't tested as much with Cygwin or like some of the other compilers that Cygwin would be using, but I don't foresee any issues with using that.
Another question, trusted user CA keys are TLS keys of SSH keys?
Okay, I'm not sure on that one, but I think that's in reference to the X509 certificate support. Correct me if I'm wrong on that assumption, but if it's in reference to the X509 certificate support, then we have just the full blown X509 certificates that is supported. Those are the same type of certificates that are used in TLS connections. That's a little bit different than the OpenSSH's version of X509, where they just pulled out certain versions of or certain portions of the certificate and used it for authentication. We followed the RFC out there for the X509 certificate support with SSH, which actually uses the full X509 certificate.
Another question, what is the IP check-X of SFTP?
Okay, can you repeat the first one over SFTP?
So what is the IP check-X of SFTP?
Oh, okay. All right, I understand now. Okay. So the IP check is just for checking like a subject alternative name in the X509 certificate. You can place an IP address in that subject alternative name that binds basically the certificate to a specific IP. So say if your host always has the same IP address, you can list that host's IP address in the subject alternative name of the certificate. And then when the client is connecting and authenticating the certificate, it can check that the IP address that it's connecting to matches up with the IP address listed in the certificate. And some clients might not necessarily, or just peer connections might not necessarily care if the IP address that they're connecting to matches up with the IP address listed in the certificate. So -X is a way to override that check.
I do have another question. What could be the reason for not enabling -enable -SSHD?
Sure. So one of the reasons is if you're on a resource constrained device and you don't care about pseudo terminals, don't even care about SFTP or SCP, you just want to pipe some kind of standard output to a different location. So not enabling the SSHD would reduce the footprint size of the library. It also would help with not having any dependencies on some kind of pseudo terminal creation.
So I have another question. Do you plan to support OpenSSH certificates?
Yeah, we've had a code change. I guess you can consider it in review, but we've had kind of the code out there for a while. There just hasn't been a big demand yet from our users for the OpenSSH style certificates. But I would say that's something that's been on our mind, but it just hasn't been as high a priority as some of the other features and additions that we've been doing.
Another question. IP check-X of SFTP is for server-side certificates or for client certificates or both?
Right now, we have it on the client checking the server that it's connecting to.
And another question, is this product using the library that is FIPS ready?
Yeah, it can make use of the FIPS ready library.
Okay, perfect. I think it's the other question I have. So thank you, Jacob, for hosting an informative webinar and everyone for joining the webinar. Please don't forget to follow us on Twitter at wolfSSL and other socials. Thank you again and see you next week.
Thanks, everyone.
Thank you.